All right. The people I don't see here are Brady and Cody and Jonathan and Jasmine. See who just came in. Cody. Okay. So what we're going to be doing is having students show their solutions to the homework problems. And I'm going to go through and have people choose which one they're going to do right now. And then I will start at the hardest one and work down, because some people just won't have a solution for the hardest one. I want people who actually have a solution to choose one they have a solution to, instead of saying, okay, all the people who did the hard one did the, explain the easy one. So, is anybody willing to sign on for the integral of the last one here? Okay, Aaron. That was volunteering, right? Okay. As opposed to saying, I have a question. That question isn't.
I'll kind of see if I got it right.
Okay. How about, okay, I can't spell Aaron, it turns out. How about the next last one? Anyone feel confident? Okay, Cody?
No, I didn't.
Okay, the third last one. Integral 24e to the 3t. Carrie. And then B. Megan. And finally A. We've gotten past the hard ones. Integral for A. Caitlin, right? Okay, now the derivatives. The last one of the derivatives. Volunteer for that? Okay, Gabriel. Next to last one of the derivatives. Anyone? I'm looking for volunteers to show their solution. Okay. Brady. Okay. The third one there. Okay, James. The second one. Okay, Jasmine. And the first one. Who wants to start off? I think this is between Nate and Gila. Okay, Gila. Okay, so what I'm going to do here is I'm going to take this and hand it off to people in order. Actually, I have to write these down in order on my paper so I know who to go to each time. Gila, Jasmine, James, Brady, Gabriel, Caitlin, Megan, Carrie, Cody, and Aaron. So I'm going to take this and I'm going to give it to Gila to start, and she will just, okay, forward and backward pages is this button up in the top right. So I'm just going to go forward to the page, and this will be Gila's page, where she is going to show her solution to the first one. And when she's done, by the way, you can erase by just using your finger, and you write with this. And then when she's done, we will just pass it from her to Jasmine and go through. And explain your process as you go through. Don't just write your answer.
Okay. So, you do this little bit, because I'm so good at explaining things. I always have to rewrite my thingy. And then you separate, please don't touch anything, the variables.
We're doing derivatives, so you don't need to separate the variables.
Oh, well, that's what I did with mine. That's cool. I don't, it's 5, and then 2 minus, nope, it's just 2.
That's the mistake I made, yeah.
Nice.
That was teacher state mistakes.
Then it's 2 minus 1, 20. Technically, there's a 1 there. And then it's 1 minus 1. And then it's just 0. It's constant.
Okay. That's a perfect solution.
I agree with you.
Where does it go to?
Okay, so now we go to Jasmine next. So hand it off to her.
What if I'm confused on my own problem?
Show what you can and ask questions.
Okay, I can try. So I did dy over dt equals. Okay. Do I put out the constant? Oh, that's right. Sorry. dt over d over dt. Sorry. So d, and I put out the 6. So I have d over dt. Should I have a dy in the first one?
Yes.
Okay. So I would have 6 dt over 1 over t squared. And then I figure out the du to find out and to put that one out, which will give me a 6 t over. Oh, actually, no. There's a different step for this, but it's gonna give me a negative 2 over t cubed. And put that back in. Give me, oh, sorry. Okay, t. T. That's my answer.
Okay, that's correct. That's all good. I wanted to see the
How I
explicit
did
part
the
that you
T
drew the
cube.
arrow for.
It's the exponent one for derivative where you n minus.
Yeah. To make it easy, if you ever get in a pinch on this, the easy way to do it is to rewrite 1 over t squared as t raised to the minus 2. And then you bring down the minus 2 and lower the power by 1.
I'm done with this. Here,
Okay,
thank you.
she's done with that. Go ahead and hand it off to James.
Okay.
If anyone has questions, make sure you type up and ask them. You know, if there's like, I didn't realize that, or I think they made a mistake like I did.
T. So, since it's e raised to the variable, you do 4 times 3 e, and it stays up top. And then that is 72 e to the 3t.
Okay, that's all there is to it. Remember, he brought down the 3 because that's the derivative of the exponent. Did you have a question, Gila? No, fantastic. Okay, Brady.
Alright, so if f of t equals 7 t e to the 5t raised to the 4th, then it also equals 7t e to the 4 times 5t.
Now, for people who didn't do it this way, you could have done it otherwise, but this is the easiest way. So just simplify it before you start.
So then this equals 7t e to the 20t. So then...
By the way, this has a full-size page. You can use 2 fingers to scroll if you want to scroll.
Oh, okay. Oh, use a finger to scroll?
2.
Oh, 2. Gotcha.
It
Gotcha.
erases 2 scrolls.
Alright, so dy dt therefore equals, this is like 2 terms. So the derivative of the first term multiplied by the second plus the first term multiplied by the derivative of the second
Now, what do we call the rule he just used? The product rule. Now, when I was a freshman taking calculus, I got the chain rule and product rule confused on an exam. And so I had a problem that just was never going to terminate, and I gave up after like 7 terms. And when the teacher passed the exams back, he proudly proclaimed to the whole school class that I had come up with a new rule of calculus. So I will never forget the distinction between those two. Now, there are lots of ways to write the final answer, and that is probably the shortest. But you can write it different ways as long as it's the same final answer, it's fine. Okay, good job, Brady. Next,
Ooh.
Gabriel, straight ahead.
Gabriel.
So I'd help with this one, and so I'm a little scattered quite on the mechanics, but I'm going to do my best to show how it worked out. Because I think the answer is right. Just getting there was a tad confusing.
I did all this work and then I added 5t.
Okay, so we had 10 to the natural log 4t squared, which was I was advised to re-represent as, whoa, this is weird, as 10 to the natural log of 2t squared.
Suppose that's one approach.
Because you can pop the square out to the 10, but now I've just confused myself, which is a little awkward. So we'll roll with it. The end result that I got to was dy dt is equal to, through simplification of a mathematician's mastermind, we got to this. Times 2 to the 8th t, which then simplified out to 20 over t. There's a t here, which I'm going to better represent. So the t's cancel here. Oh, wait, psych. I see what I did. So the 8 here, in which case I have no idea why I wrote that, because this canceled. I was left with the 2 there, which multiplied over to the 10 and became 20. They were trying to explain it to me where you pop the exponent out of the log there, but I didn't follow that. I followed it once we got to the end, though.
Okay. Let me show 2 different ways of doing the.
Snagged.
Yeah. 2 different ways of doing this. depending on how you want to start and simplify. So the simplification that was suggested to him, I find a little odd, but it certainly works. So I would do one of two simplifications. Well, actually, I would do either a simplification or no simplification. So first, let's do it as if I'm doing no simplification at all. So I'm going to do f of t is equal to 10 natural log of 4t squared. This is an example where I'm going to use the chain rule. So I'm going to start by essentially saying let u equal 4t squared. I don't know if you've actually shown a u substitution when you did the chain rule in the past, but it's just a way of making sure that I don't make a mistake. So that means that my equation is 10 natural log of u, and if I want to find df dt, then the chain rule says I'm going to do df du du dt. And so then if I take df du, the derivative of f with respect to u, I have the 10, and then just one of the things we memorized, the derivative of the natural log of u is 1 over u. And so this is my first term, 10 over u, and then my second term is going to be the derivative of u, which is going to be, since u is 4t squared, that's going to be bring down, 4, bring down the 2, t to the 2 minus 1. Now let me substitute for u. U was 4t squared right here. And now we're to the situation that Gabriel had. We can look for things that cancel. So my 4's will cancel here. One of the t's will cancel. And I'm left with 2 times 10 on the top, so 20, and t on the bottom, which is the answer that he got. So that's one way of doing it. I did no simplification, but I had to use the chain rule. And whether you write down the u or not, you still have to use the chain rule. The second way of doing it is to simplify it by using the laws for logs. I have this log of 4t squared. Well, if I have the log of a times b, I can separate that into the log of a plus the log of b. So the first thing I'm going to do in simplification is say this is 10 times the natural log of 4 plus the natural log of t squared. But if I have natural log of t squared, how can I simplify that? I can bring the 2 outside, so this is 10 times the natural log of 4 plus 2 natural log of t. Now this has become much simpler. I'll write it out as 2 separate terms, one constant term and one that has t in it. Now if I want to find the derivative of this, it's gotten to the trivial. Derivative of a constant is just 0, right? And then I have plus 20 and over t because of that rule. Derivative of the natural log is just 1 over. So I get the same answer both ways, 2 different ways of approaching it. The way they had you approach it, Gabriel, I would say would be in between. You simplified it somewhat, but didn't really make the problem simpler in your simplification. And of course, why are we going over this in class? So we can see the process and different ways of solving these and understand better. So does anyone have questions about what I did or what Gabriel did? All right, then we shall go to our next student, who is Caitlin. So she's going to be doing the first integral.
Okay, see if I do this right. So I did, we're doing the integral 0 to t to the f, and then I just rewrote it, 5t squared and then you just take an integral. So it's 5. What'd I
You're pressing
do?
a button, and that's what's making it happen.
Awesome. I can't.
Around the other direction.
Oh my word. I'm sorry, guys.
It's a problem that I've had. Hence, I know what the problem is.
And you just simplify it. And, oops. Okay, that's good enough. This is 10. And then you have to do the whole.
I'm going to stop here. The cubed has to be on each term, not on the parenthesis. In this case, it's not going to make a difference because you have minus 0, but it needs to be t
But
final
in the
cubed
future?
minus 0 cubed.
Okay.
Well, no, the parentheses were fine, but you need to have parenthesis t final cubed minus 0 cubed. Yeah, that's
Got it. Okay. And then you just simplify.
Okay, perfectly done. Now a question for everyone else. She did it right, I'm not going to ask her. Why is there no plus c? Yeah, because it's a definite integral. That's only when you have the indefinite integral. In this case, the plus constant turns out to be 0 because our lower limit is what set that plus constant part. Okay, very well done. Thank you, Caitlin. Next is Megan's turn. Do you have a question, Gila? Well,
That's the fun role here.
what you're doing is you're putting your limits. So you have, let's take the first one. She had 5/3 t cubed and then the limits. So she put 5/3 t final cubed minus 5/3 0 cubed. And so she just factored out the 5/3 because it was part of both of them.
Could you just multiply them all by 3 too to get rid of the fraction?
That would be a different answer.
Oh, okay.
Maybe I misunderstand.
Like multiply each one by 3?
So for instance, you would have 5 t cubed minus 30 t squared.
Plus 51.
Yeah, that would be 3 times your final answer, so that wouldn't be a correct answer.
Because if there's another, you don't do it, so there's a
Yeah, that would be 3 times the integral.
Oh, okay. Bleh, okay.
Yeah, it did repeat.
So this is an alternate form then to plugging in, kind of like minus minus initial. So, and I think this, I'm just still kind of understanding Gila's question, where you would do the whole equation for t sub f minus the whole equation for
Yeah.
0.
She did term by term rather than the whole equation and then the whole equation.
Does this work
Either way,
across the
it's correct.
board?
Yeah.
Oh wow, cool.
As long as they're separate terms.
Yeah. This just looks
It
fun.
doesn't mess with the subtract. Because
No.
you subtract like terms anyways. Like,
That's a lot
Okay.
Okay, Megan. Just use 2 fingers to scroll so we can see it.
Okay, so I had
I'll preface this by she got the first tricky one.
who, her or
You
me?
did.
Yeah. Now I feel unsure about my answer now.
in there.
Okay, so we have f of t equals 6 over t squared. So I rewrote that as 6 times t to the negative squared. So then I would take the integral from t final, or 0 to t final, of 6t to the negative square, negative 2. And then I pulled out the 6 before I even took it.
Make sure you put the dt there.
Oh, yeah.
Because if it was dx, your answer would be completely
Completely different, yeah. So then when you take the integral of this, it would be 6 times, well, how do I erase it? Oh. I'm like actually so nervous right now. Okay. It's actually t to the negative 1 over negative 1 because of the rules of integrals. You would add 1 to the, yes, and then divide by that. So that would be 0. And then I rewrote it as 6 over t. Oh. I don't know really where to go from
It
this.
should be a plus sign, but it doesn't really matter because what's 6 over 0?
Undefined.
Yeah.
Undefined. So what's your answer?
The negative 6 over t, yeah. Oh, it's
If I
nothing.
have 5 plus a random number, I don't know what the answer
Yeah, I
is.
guess.
The first part doesn't matter if you don't know the second part, so the answer is undefined.
Well, I got it wrong.
This is originally going before you substitute the t for tf minus 0, means that you get a correct answer on this problem. Because you would end up at the bottom. Your bottom, there was a thing before where you could take it by parts, where instead of replacing your t with tf and subtract it,
But you could do like we did before, you can factor out the minus x and then have parentheses 1 over t final minus 1 over 0. But you still have the division by 0 there.
So replacing your t with what?
Well, when you put in your limits,
Yeah.
you're going to have...
You're going to undefined, but it's what we wrote before, at least what I understand what we wrote before, on the last one, where you would put it, she was replacing t with tf minus 0, right?
She replaced t with tf, and then she replaced t with 0. That's why I told her she had to have the cube was inside. She couldn't have tf minus 0 cubed. She had to have t cubed minus 0 cubed.
And then put it back in as if you could, yeah. That's what I was saying when you, I thought you were saying that you could just replace it that way. Probably.
This here is correct.
Okay. Yeah.
Okay, next Carrie. Bring it on back here. Two fingers to scroll.
So we have
Okay, perfect. A lot of people forget that e to the 0 isn't 0, and they tend to just say it's 8e to the 3tf instead of forgetting it's got that minus 8 stuff. Any questions? Okay, next up is Cody. There you go.
Oh, is that not what I'm supposed to do?
Use two fingers to scroll up, just below on the right.
Uh-huh. Okay. So, integral. Oh, this is weird. 7t e to the 5t to the 4th. Pull out the 7, simplify the 5t to the 4th. And I suppose
Make
if...
sure you put your DTs in there.
Yeah, oh, sorry.
I said
Yeah.
on last week, there are some textbooks that decided not to put in the DTs, but to me that's an abomination.
I mean, there's only one variable, so it's not a huge issue. Is tabular okay, or should I do it long form?
Is what?
Is tabular method okay for this, or should I do it long form to show?
The term tabular, I don't know.
You don't? Oh, okay. I guess I'll do it long form.
Well, what does it mean? You might
Um,
teach me a thing or two.
Where you'd go, I mean, it's the same thing as long form, just shortened. So you do te to the 20t is your, your dv. Wait, no, yeah, dv. And then you put it. Oh, whoops, that's not even what I wanted.
Let's do it long form then, because that wouldn't be DV.
Well, and then you just do t. You take the integral of one side. You differentiate, and one side you take the integral of. Oops, the t shouldn't be there. That's why. And then. And then you just you multiply the left side by the right with where the arrow is. My handwriting's really bad, so. And then when you have add, it's a positive, and then when you have the minus, it's a negative. And then that would be your indefinite integral. So I should probably put the thing on the end. Running out of. And then simplify that to, let's do e to the 20t over 400, 20t minus 1. I guess don't forget our 7's out front. And then just put in your numbers. Oh, there should be a T out front, shouldn't there be? Yeah. I should. No, wait, no, I already have the. I should not try to read my handwriting and actually solve the problem. Missing. No, that parentheses there. Minus. I'll scroll down. I'm putting in the 0. E to the 20 t. No. No, that should be a 0. So just 1 over 400. That shouldn't be a 1. Wait, yeah, that should be a 1, right? Yeah. Okay.
The last one should be a plus. This is minus and minus.
Yes, there we go. That's
Okay,
what I was
now
missing.
that's correct. At least I believe it is. It's kind of hard to get through. But I'm going to go ahead and show
Do
it
the long- I have
what
the
I
long
think you
form,
would have
too.
considered the long form. What's the, I mean, you've already done it. I'm not going to make you do it again. What's the name for the method he used here?
Tabular integration.
The general method that you use the tabular in.
Integration.
Integration by parts. That's the general name for it. And since I had never seen this tabular method, I'm going to guess that I'm not alone and other students also haven't seen that. So that's why I'm going to do it again so that we can see the more traditional approach. I just realized I've been having everybody... This actually has layers, which is really cool. We've been on the top layer for all of these, so I'll change to the next layer here as I do mine. Okay, so just putting the problem here so I know what I'm doing. Switching to layer 2. So at least the last one. Now see, I can go over this and it doesn't erase it. If I write on it, I can go like this and it only erases my writing. See how smart that is? Okay, so I start by simplifying this as everyone has done. And so I have the integral from 0 to t final of 7t e to the 20t dt. And just like Cody did, I'm putting the 7 outside because it's just a constant. And then we have integration by parts. A potentially confusing method, but a powerful method. What you have to do with integration by parts is recognize that I could view this as two functions multiplied by each other, and one of them I can simply take a derivative and the other one simply take an integral, and then if I put those together I can do the integral. Now it's not always that simple. You might have learned recursive integration by parts as well, where you go through integration by parts like 2 times, you get back to the initial equation, and then you can use actually algebra to find the answer. So in this case, I'm going to define a function u that I can easily take the derivative of, and that's going to give me, when I put them back together, something useful, and we'll see in a second. u is equal to t, so that means du is equal to derivative t, just dt. And then I take the rest of the function, and that's going to be my dv. So dv is equal to e to the 20t dt. And now I'm going to just integrate that with no plus constant and no limits, and say v is equal to 1 over 20, 1 over, yes, that's right, e to the 20t. So I have my u, my v, my du, and my dv. Now the formula for integration by parts, which, you know, if you want to study it, you can see there's a very simple reason where it comes from, is that this integral of u dv is equal to uv minus the integral of v du. Now I have limits here, so I'll go from a to b. Got to put my limits on the front part and on the second part. And so the work that Cody did was, in effect, finding the u, the du, the v, and the dv, and multiplying them together to get this form. That's effectively what he was doing. So, using what I have written out, my u and v are very simple. That's going to be t times e to the 20t over 20, going from 0 to t final, minus, and then I need to have my integral from 0 to t final of v, so my v is e to the 20t over 20, multiplied by du, which was just dt. And now I have to do that second integral. Minus. So doing that second integral of e to the 20t is going to be, well, I did it in my head when I went from dv up to v. I did that integral in my head. Hopefully at this point we see that. So I'm just going to do that integral again. So that's going to be e to the 20t over 20 squared, as Cody wrote. I should actually combine this into one thing and not, if I have the parentheses and it looks like limits are just on the parentheses, this here is more kosher writing. And now I just have to put in the limits, which you saw Cody do. So that's t final e to the 20 t final over 20 minus 0 e to the 0 over 20. 0 e to the 0 is still 0. And then minus e to the 20t final over 20 squared minus e to the 0 over 20 squared. And then we put all the pieces in to get Cody's final answer. And I'm going to have it in a different order, but it will be the same answer that he had. Oh yes, that was doing my U and V part, but I dropped the 7 overall. So everything here should have had, thank you for that, everything should have had times 7. So I've learned a new way of doing it from seeing Cody's work. I've shown you the traditional way. And to do it the way Cody did, as he said, he actually, in his written out work, he did it this way. To do it, well, Yeah. To do it the way he did, you need to understand this way. You don't just, well, there's a mathematical rule I don't understand, but I'm going to churn it through. You want to make sure you know what you're doing. So does anyone have questions on this? Okay, then we will go to Erin for our last problem. Erin the Brave, I shall call her. She volunteered, knowing that it was the hardest.
Okay. Second here in this last part. Okay, I just noticed something about the last part. We'll go with it. Okay, so we start off integral 0 to TF, and I'm going to rewrite it with the 10 on the outside. Natural log t squared dt. Okay, and we're going to do integration by parts, so I'm going to make this be my u and this my dv. So I like to write it all out.
At this point, we only have 3 minutes, so go ahead.
Okay. Perfect. Okay, so we're going to do the integral u dv minus, or equals uv minus integral v du, and that's 0 to tf and 0 to tf. And so this part is going to be my u times my f, or my u times my v. So t natural log 4t squared from 0 to tf minus 0 to tf t times 2 over t dt. And do you want me to show how I got my du, my v and my du?
At this point, because
Okay, perfect. Equals,
on your solution, yes, but right now we don't.
yeah, natural log 4 tf, or,
TF squared.
yeah.
I see your brain is going.
Minus, and I just realized this would be 0 times natural log of 0, which should be undefined.
It is, the rest of it I think you can see. I want to focus on that one term, right? Because we're almost out of time. The reason hers was hard is because of this term. 0 natural log of 0. Natural log of 0 is minus infinity.
Mm-hmm.
And so we have a 0 times a minus infinity. You may or may not know that that doesn't mean that it's undefined. It could be undefined, but it might not be. And so that's where we have to use L'Hopital's rule. And because we'll have like 2 minutes, let me take over just for time, because I know where I want to go with this. So L'Hopital's rule is a rule used when you are at a limit of something that is of the form of zero over 0 or infinity over infinity. So now if you look at this, it's 0 times infinity. But 1 over infinity is 0. So that is still of the form of 0 over 0 or infinity over infinity. So what I need to do then is take this, my actual function here, since I'm doing a limit, the actual function was the limit as t approaches 0 of t natural log of 4t squared. Right? That's what we were doing here. And so I need to recast this in a way that looks like one of those two above. And the easy way to recast this is to write as limit as t approaches 0 of natural log of 4t squared over t to the minus 1. Now that's infinity over infinity. Well, minus infinity over infinity, but nobody cares about the minus sign. When you have this form, then L'Hopital's rule kicks in. L'Hopital's rule, I've seen his name written multiple ways, which I'm not sure why. Some don't have that S in it. Yeah, that's enough explanation right there. It's French. Okay, so what you do is you take the limit if it fits one of those two categories, this limit is equal to the limit as t approaches 0 of the slopes of how rapidly they were approaching their limit. So applying that in this case, I'm going to have the limit as t approaches 0 of derivative natural log of 4t squared. She already, has done that. The derivative is going to be, you take 1 over 4t squared multiplied by the derivative of the inside. So 8t, 2 over t on top. Derivative of the bottom is going to be minus 1 over t squared. Put those together, and that's going to be minus 2t. What's the limit of minus 2t as t approaches 0? 0. So after, and only after doing this work, can I come back and say that this term turns out to be 0 because of L'Hopital's rule. Before doing the work, I didn't know that. And so I have this in here so you can see using L'Hopital's rule. I swear for next year I'm going to change my problem so the L'Hopital's rule doesn't come out to be 0. Because you tend to think, it came out to be 0. Why did we have to do all that work? Well, because it doesn't always come out to be 0. All right, we're past time. I'm sorry I went over by a couple minutes. I just wanted to make sure we do have a coverage of L'Hopital's rule. Now, are we going to see L'Hopital's rule? Very rarely are we going to see it. But I just want to make sure people are aware of this when we're putting the limits. You have to be paying attention to this. So I will actually post this on YouTube so you guys can review the lecture. And I will save this so you can look at the work we did as well. Your work is due